Hello and welcome back to another session of serde-yaml. It's Byron speaking, and I am in the middle of a grunt worker phase where I have to put an additional probably like 20 or 18 examples into my test suite, and these examples are based on the examples given here. We should be able to do everything that is listed here except for the comments here. And I wonder, I kind of use the Python implementation as a reference and say, well, it should probably be able to do this. This is the stuff we can't do because I don't think I will be able to, or I will be implementing anchors here. So no, probably not, but the Python version can possibly do it, provided we use the same object for this. Yeah, so I guess I will just let this fail, but assert failure. Failure is okay, but I will put this into the test suite nonetheless, because we simply cannot do it. But this thing here is something we can definitely do. In Python, for sure, and in Rust should be possible as well. Oh, what did I close? My Python file. I did. All right. So let's see. That's the data here, and let's just copy this part because the two comments part. Something we will gladly or sadly have to skip. So here's the data. It's a dict of lists, and yeah, nothing else here. Just a dict of lists. Fine. Must be an ordered dict though. So let's do this. With explicit document marking. D is an ordered dict, which has HR associated with a list of things, like this. Oops. That is number 1. And number 2 shall be RBI. And another list of things. So let's do this. Like that. Good. HR, RBI. We are nearly done. That's ordered dict here. And now we just have to dump it. I think now we have to go back to the normal dump. But specify that we want to have explicit start being true. And what comes out of there? I think an exhaustive list as well. So we want to have the pretty printing and explicit start true. So that's basically the ops we want to have. So because we are kind of always adjusting our state here, we can set this to false again. And then I should be able to use the options here. And it should just be what I expect if I do not forget to change the example ID here. Look at that. It is missing something. What is it missing? Oh. Actually, it even tells you that something is wrong. Unindent does not match indent. Oh. 1, 2, 3, 4. That's sad. Does that match? It does. So here it doesn't matter the indentation. But where does the indentation or the unindent not match? This looks good as well. Oh, probably is this one here, huh? Oh, actually, I don't know what I was thinking here, but that's totally wrong. So now this might work. Let's have a look at the data. That looks exactly the way it's supposed to work. Awesome. And yeah, it's a struct in our case with vectors of strings that we will initialize accordingly. So yeah, let's have a struct. Pub struct example 229. And yeah, I guess I will just copy the Python version here for reference because it's a bit more concise. So it's pub hr, a vector of static strings. So this means we only support serialization here. Oh no, wait, look here, we also support, oh no, game event uses static strings. So deserialize isn't implemented for static strings, which makes sense because you cannot create a static string at runtime. So if you ever want to test this with deserialization, we have to just make these into real strings, which are heap allocated. All right. Static. Yeah, static string, I have that here. Let's just copy this. Let's go for RBI. Now we can implement another beautiful default implementation, which shall be example 2.9. Oh, come on. Yeah, the sad thing is once you lose your completion, you have lost it. You have to kind of try again. So it's HR, which is a vec of these things. Look, I can actually take this one out of here. And RBI is a vec of these things. And that should yield exactly the string that we have gotten from our Python implementation. Right now, obviously, that is not the case. Everything fails, but that's how it starts. So 2.9 to 9 to 9 to 9, awesome. So the panic stuff we don't need. Let's take this example and adjust it for 2.9. There we go. 2.9 to 9. So that should compile. It does not. We have, I mean, I had times where this actually worked for me. Oh, look at that. I always copy just part of it and then I mess it up. So now this works. Works better. We're still not through with it. See, serialize is not implemented for 2.9. What? Oh, true. It is not implemented indeed. Now it is. Cool. So that runs at least, even though it obviously fails. Good. Now it's the big question. Yeah, as I said, I would like to have it. The Python version can do what it does, but in Rust, I don't think we will support that. So yeah, the options we can still use. That's a cool thing. And here, semi-sosa, it's just a single string. It's the same structure, right? Except that semi-sosa now has to be the same string. So let's call it S for string and put semi-sosa here. So that, I guess, would work here, but I'm not quite sure. Let's see. We will find out the hard way. So the options, fortunately, are exactly the same. What is it? 2.10. Is this the same data? Yeah. It is. So possibly that will work as expected, except for the white space mess up that happened again here. Why would that happen? Oh yeah, and I forgot the docs here, just for completeness. Good. So 2.10. 2.10, there we go. YAML dump ops, same options. Should do something. Oh no. Semi-sosa. So where did I copy this? I guess, well, it will actually tell me, right? 135. See, here somewhere, I copied a non-ASCII character. Oh, and I do not know where that happened. Maybe it's gone now. It's gone now. Nice. So that worked. But look, it also doesn't do it. So anchors don't work. Oh, no, wait. Yeah, anchors don't work here either. Interesting. So yeah, let's have a test. How do you specify assert failure? Rust test assert failure something. Test fail. Rust testing guide. I hope that's not too old though. Fail. Yeah, how was that again? I should fail that one. Okay. So let's do that. And yeah, we don't have an example for this because that makes no sense. We'll just panic and say that anchors are not supported. Neither they are they seem supported in PyYAML, which is interesting. Is it or is it not? How do they specify it? How do they call it? Appears twice in this document. Okay, I think it's called anchoring. Yeah. So, oh wait. Anchors and aliases. Oh look. Note that PyYAML does not support recursive objects. Makes sense, I guess. So using YAML, you may represent objects of arbitrary graph-like structures if you want to refer to the same object from different parts of the document. You need to use anchors and aliases. Anchors are denoted. Yeah. Well, I understand that the deserialization works with that. But the serialization doesn't appear to be working like that, or it doesn't work with simple strings, just with dicts, but that would make no sense, would it? Maybe it is implemented that way, who knows? Is there more about it? Anchor token. Yeah, they also have some sort of scanner interface so that you can do what you want to do. But that could be, this token stuff could be interesting for the lexer. Start mark, end mark. Interesting. Produced by YAML scanner. So the scanner, I think, is a lexer, right? For them. The PyYAML scanner produces following types of tokens. Yeah, this looks like the lexer. Interesting. Start and end, see? So that's something we will definitely look at for the deserialization. Let's try not to forget that, because it could be a good hint at what's actually required for the lexer to work. Yeah. For serialization. All right. So this is, yeah, the question is, should I do anything here? Because this one will be unused now. And this will light up in my compilation, I guess. Variable D is unused. Really? Oh yeah, because of the document stuff that I don't yet use. Then let's fix this right away. Every error we do not see is a good one. Or every warning we do not see is a good warning. Oh no, wait, this one we use. This one we do not use, and this one we do not use. All right, to 9 to 10. And we want to mark it with should fail. I do hope this actually works, because we will not support this. Oh, it's currently unknown to the compiler. Oh, they might have changed this. They might have renamed this. Oh, damn. Yeah, so that is too old. It's Rust 0.13, damn it. Yeah, probably I want to have the Rust book here. This might have the information that I was looking for. No, not in the reference. Maybe here, testing, unit testing. Maybe here there's, I don't know. That's the guide, the style guide. So I'm guessing they don't have that here. No, they do not. Okay, let's get the book somehow. Rustlang.org. I closed the book at some point because I thought I wouldn't need it anymore, but yeah, there you go. Let's take the latest. Yeah. Test. Benchmark test, testing. I think here we should have this information. Test attribute. There we should have some should fail. Should panic. See, this is what this is now. Should panic. Huh, it's better because it actually, I actually call panic there. Cool. So we have one non-failing test, which is the panic stuff. That's good. Anxiously not supported, neither. They seem supported by PT3 for serialization. Good, I guess. I might want to add an assertion here or something. Yeah, why not? Because we actually get something like this. Even though I don't care about the result, right? So I don't have to assert for this. I don't care about the Python feature set. Might not be a, might not be a bad thing to try that. Why not? Let res shall be this kind of string. And we can just assert that res is whatever this is. Should be the case. Huh? Does it add a new line? It adds a new line. So we need that here as well. Yeah, and my comment is not actually supported by PT3. At least not by the pure Python implementation. Maybe libyaml does it, but Python itself not. Oh wait, did it fail? Oh, assertion is always true. Oops. Okay, that worked. Cool. So the assertion holds true. That's good. We can move on. And go ahead with to 11. Mapping between sequences. Wow, what is this? I've never seen that before. I have no idea how I would specify that. A question mark and space indicate a complex mapping key. Complex mapping keys within a block collection key. Value pairs can start immediately after the dash colon or question mark. Okay, so this is a mapping between a list of these two and another list. And this is the same thing, but different values and a different style. Whoa. All right, let's see how that works. Does it work in Python? I have no idea. I will try. So the style we will have to change because that doesn't work. I have to normalize this probably to be maybe a non-human readable version or a less readable version. I'll be fine with that. So good. The key has to be something that is static. So we probably want to use a tuple there. And yeah, let's see if that works. I'm not sure about Python here. Rust could possibly work, even though I am entirely unsure if the current implementation can handle this because JSON can't do that. So this might even actually crash when we try to build it, but oh yeah, I'm not sure if it can do that. It should. I'm afraid of this. That's going to be a tough one. And I'm not sure if we want to support it or not. So, but we might want to add it just to say that at least we say it should fail because it doesn't work. But let's see what this guy can do here. Let's see what Python can do. Considering the maturity of the Python version, this might work for us. All right. So D is an ordered dict. And the key here is a tuple of two strings. Oops. Like that. Like that. Okay. And yeah, not to forget, that's just the key here. And the value is a list of, that's just a string in our case. And the second value shall be, I'm using tuples here because I think Python doesn't like mutable items as keys, so I'm using tuples. But this should boil down to the same thing here. Maybe like that. Okay, and now we have a list of things. Oh, actually 3 items. Fine. Yeah, I messed this one up. I could have done all in one go, but hey, a few extra key presses, it's fine. So that's a list of things. Let's close this one. So that, yeah, I mean, I think that is valid Python. That's the least thing I can say about this. And yeah, let's just try it with these options here for now. That's 211, right? Yeah. Oh yeah, it's actually written right in front of my nose. 211. And right, oh yeah. So that is that. Let's see what it does. It did something, that's good. Look what he can do. He did it. I'm not sure why it writes Python tuple there, probably because it is a tuple and not a list. So in order to put it back the right way, it needs to do what it did. I understand. Let's see if that can also be a list without freaking out Python. One of them should be enough here, just to see if it works or not. Yeah, see, unhashable type. Is there a frozen list or something? Python list freeze, is this possible? So, freeze. Well, that's not exactly what I meant with freeze. You kind of prevent writes to the object, that's okay, but there's nothing that it would be built in. Upgrading all packages with pip requirements, pip freeze, freezing your code. Nope. Yeah, that's a bit annoying. So in Python, I can't really get rid of this tuple stuff unless I want to add another sort of override to make sure that all tuples are represented as lists, which would be fine with me, actually, especially for our example here. Yeah, so that is that. Shit. Yeah, the only thing that shouldn't be here is this tuple thing. And also, I'm not so sure about the indentation here. Why is the indentation so weird? For the keys, is this supposed to be like that? Is this similarly done here? No, it's not. So is this valid YAML? Do I have a YAML parser on the command line? Brew, search, YAML, is there something? YAML CPP. What's YAML CPP? Build using C++. Okay, that's probably just some library. Yep. Just a library that I do not need. Good, so there's no command line YAML tool. Sad. I wouldn't be sure about what Python outputs there. Yeah, so I guess I can just add this thing directly because we cannot produce it really in Python. I think that's what I want to say. No, can't produce the example in Python as we must use tuples for the keys which don't translate to lists. Yeah, anyway, let's do this. So my string is this one, Detroit Tigers, blah, blah, blah. Let me put it all the way to the left, not messing up the spaces. I think a new line is usually what you have at the end. Probably. We will see about this. And then this is, oh, actually, this is not what we want to get. We would get this, because it's the same stuff for all of them at the very least. And then we have Colin. I don't know about the new line. I think the new line is something we might not actually get unless we have some special flag that puts it there. And that goes away, this comma goes away. Space, space. Okay. So that's how that would look like here. And we can change the style if we like, but for now. So that's to 11. No dumping. Just pass the string directly. And should be fine. Make test. That is that. That could be doable here. Okay. Interesting. We build the data structure now. So that's what again? I think I would call it a tuple of things, because that's for us a tuple. The question, yeah, and because we have the data structure, we can parse it back into the data structure in theory. But let's see if the JSON stuff works or crashes on us. That's also something I cannot even estimate. And where's 210 fails actually, right? That's why we don't have it. All right. 210 should panic. And yeah, what again? This is a hash map. I call it a new type. Let's just copy it. I would call it a new type that is to 11 and is a hash map of a tuple. Yeah, should I use static string? No static strings for deserialization, but for serialization this would work. Yeah, but I'm kind of interested in deserialization as well in this case, so let's make it a string. That's the key. And the value is a vector. Yeah, I do wonder how this, yeah, I have no idea. Let's just try it, right? That's how that works here. And then this is a vector of strings as a value. All right, and then we can just put the default implementation here for 211 and say example 211 shall be a new type of a hash map h that I just put here. And let mod h be a hash map, hash map new. Oh, wait a moment. Oh, wait, it has to be a hash map. Oh, look at this. So I might get into trouble now because of ordering. Usually I would obviously make this a struct, but we can't have a struct with a key like this, a field like this. That doesn't work. So we might hope that if we create a hash map with just 2 entries, maybe we just use 1 entry. Yeah, and if in doubt, I would just make it so that it's 1 entry. So that way we do not have a problem. Yeah, let's make it 1 entry because the second one doesn't really matter anyway. Not for us. And thanks to our ordering issues that we would otherwise have. Yeah, I think that's how it's gonna happen. So just one of these guys. And just 1 item here. Why not? So, hash map new, h insert. We are going to insert a key here that is a bunch of strings. To string. And another one, Chicago Cubs. To string. And then we go with a vector. It only contains a single, what is it? A single string, which is this one. 2 things. First of all, let's get rid of this stuff. And yeah, that now we are done here. And that is that. So we didn't get that. No, something is wrong here. This is the tuple, here it ends. And here, yeah, so that is now correct syntactically. And that should be that. We have to add serialize, so, and deserialize. Like this. Good, so in theory that does something for us. Let's see if that compiles. We get through the build phase, that's good. Oh, mismatch types. Oh, true. Forgot the 2 string here. I want to put this onto a separate line then. Like that. Okay, so that should now be finer. We don't use it yet, so no need to be afraid of anything, but that will happen now. To 11, right? We need an assertion here. And it should just be as easy as exchanging some numbers. And let's see if that works or not, or if it fails while unwrapping. So 211 fails, but how does it fail? Where is it? Where the heck is it? I must have overlooked it somehow. Ah, here it is. Okay, cool. So it produces something. So that is interesting. How does that even look like? Let's replace all ends with new line. Now it's a bit easier to see. So we have is this even valid? Yeah, let's kick. Let's kick these ones as well. So here we have a mapping. Yeah, look at this. I don't know if this is valid JSON, but it's definitely kind of getting it right. Even though I'm not sure why it would put a list around it. Is this standard in JSON? No, it should be just one object. Interesting, definitely interesting. Or maybe the list thing is for the enclosing structure. Ew, so that could be a problem for our new type stuff that we do here. Because this has nothing... Oh yeah, the new type. Oh, damn. The new type is technically a list with one item, which is a hash map. And this is why we have a list here, which could kind of destroy all of our output. So we should get rid of these new types. And the only reason I have these new types is that so that I'm able to implement. But you know what? I think I can also, so that I have a name for these and can implement default for them. But I think I can implement default for, you know what? I think, what if I have a type definition here? Let's try that. Let's say pub type foo implements serialize. I don't know if that works, but maybe it does. And should be this. So now I should be able to implement something for it while still doing what I do. Does it work? Nope. Because this one fails, the build fails. So it apparently doesn't like type definitions. Internal compiler error. Compiler error expected item struct or item enum. All right, see, so we can't put this onto a type definition. Kind of makes sense. Well, it's just not implemented. I don't think it necessarily makes sense, but it wants to tell me that I can't do this, even though, yeah, maybe that never worked with derive default. Does that work, for instance? Look, derive default actually works. No, Actually not. So it's kind of fine to fail in this case, I suppose. Yeah, so the auto implementation I don't get for this kind of type. Oh man. Yeah, well, I might adjust my expected result then, you know? I think that could be fine. I could just put another list around these and then I would kind of have the expected result, and well, that's just how it would be then. Even though I'm not a big fan of messing around with my results that way, because I wanted to get the exact same results as presented in the documentation or in the spec. Maybe I can still get it. Maybe I can do something. Like have a flag that deals specifically with new types, even though I don't think I know that this is a new type. To me, this is probably just a tuple kind of thing with one item. So I probably won't know that what this is. Yeah, so I can't fix it. Yeah, anyway. That's how that is. But for JSON it works. That's quite amazing. Probably it's not vetted JSON though. So it's kind of a bug. But anyway, it's not a serious thing. I won't even report that. All right, we are 41 minutes in and did kind of 4 items here in total. Compact nested mapping. That's an interesting one. Probably has a lot to do with how we serialize data, and I'm curious how Python does that. So what do we see here? We see that there is a list of dicts which is specified in a very compact way. And do we have something like compact? Nope, we do not. No compact stuff. Yeah. So I guess even serde-yaml will not provide us with that particular output. But yeah, I will not even try. Let's save that time. Instead, I will just put it in and generate the respective code. So this is what we want here, except for the comment. We do not want that. Here we go. S is this, pretty much so, yeah. Let me put S here. It's 212. And we want to have this one as well. So this is something we want to be able to specify, or at least to get. And yeah, maybe. Actually, maybe Python does it automatically. Let's try it. Let's give him a chance. So yeah, this is number 1 here. We will just disable this and instead go ahead and have D, which is a list of ordered dicts. With 2 items each, like that. So that's going to be item, which is super hoop, and like this. Quantity is 1. There we go. Basketball. Quantity 4. And here we have big shoes. And quantity 1. Awesome. Yeah. No, wait. Wrong. Let's take this out of here, because that must be an individual order dict respectively. And there we go again, like that. So that's the data that we want. And I think I want it pretty. So I just go with the pretty opts here. Do we have it somewhere? Yeah, that one. So let's see how that works, huh? 212, dump data D, options pretty. That did something. Look, it actually does it. I just need explicit. I think I could even go with opts, huh? Yeah, so you have the explicit start here now as well. Awesome. So it does it right automatically. Good. Fine. Fair enough. Let's kick this. And that. Good. Now, yeah, so that's structures for us. Simple structures. Item, quantity, like basket item, cart item. Let's call it cart item. Yeah, that's prepared for deserialization as well. So let's use strings here. We might have to touch this a few times anyway, but for now, yeah. So pub struct, cart item is what? I think I want to have this data here. I want to have this data here. Thank you. And now we have item, which is a string, and quantity, which shall just be a U32 for good measure, maybe even a U64, but I don't think this will matter to us at all. Not at all. Good. And now we just have, yeah, once again, we have this issue that we now want to have a list of stuff that is also a new type so that we can have default implementation here. But I think I should start doing it correctly, because now that I know I have this issue, probably want to have a constructor and not do default. I will just have to say something like fn example to 11 new. I will not adjust the other ones, I guess, not just yet. So that returns a vector of cart items. And that's what I have to call now to get this new thing. So I think that should be enough. And there we go with cart item. Item is super hoop to a string. Quantity is 1. Now we have another cart item. Basketball, quantity 4, and then we have some big shoes. Big shoes, quantity 1. Awesome. So that is, I think that's the new style. That's what we want to do. I will adjust this once we work through the individual examples, but from now on, I will just keep doing it like that. This means for the test case, 211? No, wait, it's 212. Huh? 212. This can go away. Structs. Oh yeah, it must be pub as well. That's quite important. 212 structs example 212 new, right? That's the structure. And now we can just put it there, compare it with 212, and we are done. So that should work. Let's see. Let's see if it actually does. And then we have 50 minutes in. Each of these examples takes some time to set up. And yeah, I wonder if I should continue or not. I think I want to continue just to get an idea of the flags that I will need. Maybe I have an idea already and should fill them in. Okay, so considering I'm at 212 now, I think I should review this and see if I have an idea for flags that should be supported, even though I don't want to get ahead of myself, which could be making a mess. Now that we go with, okay, what's next? 2.3 is scalars. 2.4 is tags. I'm not sure how I should make this happen in Python. Antex nodes are given a type depending on the application. Yeah. I don't know, I should produce that. And the examples in this specification generally use the sequence map and string types from the failsafe schema. A few examples also use the infloat and null types from the JSON schema. The repository includes additional types such as binary, OMAP, and set, and others. Yeah, so this is also something that is relevant to the serializer, depending on the type. But this could be interesting for us for the basic types, right? For float and stuff. There, some sort of mapping could be used that further specifies how something should be serialized. That could be interesting. Right now we don't have that, but this could mean that we want to have schemas that you can also specify in the options, like a borrow to a schema or something. And we have some statically allocated ones that are just there, even though I don't know how to statically allocate a complex type. I think that doesn't work as constant anyway, but we can produce it at runtime. Yeah, anyway, I'm just babbling, just talking, just saying words right now. I think it's late enough to say to call it a day. I won't finish this tonight. Probably will take till midnight to have all these examples, and maybe it's not even, maybe I should go ahead and do some actual implementation here. Because originally I asked myself, how do I do this with the block and with the structure types like block type and flow type? This is where all this started. But I also wanted to have an idea of what's going to happen. So yeah, this is how all that came to life. Yeah, I guess I want to make a commit and call it a day and let it sink. Because a lot of stuff has been done, I think. Yeah. Tests. Add examples to 1 to 12. Each example is serialized by the Python implementation, just to see how it, just to see if it can produce the desired output, including in conjunction. Oops. With a Rust type that is serialized in a custom, in a per example test to check against the string produced by the Python implementation. We should be able to derive the required set of options to configure the output accordingly. Yeah, so I do believe that it's kind of impossible. I'm just looking at the sky and there seems to be a rocket launching from the angle that I see here, but could just be a plane that is far away. I don't know. Anyway, from the options I've seen so far in the Python implementation, it doesn't look like it can produce JSON style code or JSON style output. So this is something I want too. I think it can be handled with flow style, maybe if an extra flag that kind of makes it happen. Probably not a big deal. But yeah, I want to be sure that I have a chance to get everything right and have some sort of step-by-step or way to do this in a step-by-step fashion. But I have the feeling that we will touch a lot of stuff in order to do this. Output accordingly, yeah. We are missing about 26 maybe. 16. Well, actually maybe 12, about 12 additional examples, and should probably start filling in the options we see so far, because there are a few like explicit start, explicit end that we wanna add already, because that's something we need for Python as well to make it happen. But yeah, this is just the starting point here. It's quite complex, I must say, so this will definitely take a while to get right. Man. And this is the output, right? Oh no, wait, that's the fixed stuff that has been generated. So we didn't add so much actually. A few hundred lines of code, but this is generated stuff that makes the bulk of this commit. Okay, let's push this and be happy for now. And I must say thanks for watching. Have a great day. See you tomorrow.